15 higher level question. Okay, what I'm going to do is I'm going to orientate it in this direction here and draw it down my page. Okay, so we're going to start off with our plan view. We have to convert all of our measurements. This one's to 50. So if we take our calculator and we multiply them all by 1,000 to start off. So if we take all of our measurements and we multiply them by 1,000, so that's 1.500, oh sorry, 1,500 divided by 50 gives us 30 millimeters, so that's going to be 30, 30, 30, 2250, 2250 divided by 50 equals 45, 30, 30, 30, 30, and this is going to be 90. Okay, so there's all of our measurements for that, and then we look up here, this is going to be 90, that's going to be 3250 divided by 50 equals 65. So all my measurements are now converted on the sheet, and I'll put them to play. So we're going to draw our image here at 45 degrees. Going to be 120 millimeters in this direction, so we start off with and then every 30 millimeters is a glass panel, 45 in the opposite direction, for a total of 90 millimeters. 45 would be halfway, and 90 would be where it ends. Half of 45 is 22 and a half, which will then give us this glass panel here. So this is corner A. We have our spectator in a vertical position from here. The distance that the spectator is from corner A is 90 millimeters. So put that in there.
If you had to have
S. Now, I'm going to take my furthest point on the left, because now that the spectator is standing there, we want to take a picture or capture the image of the greenhouse, the lovely greenhouse that it is. So we want to be able to point our camera in the right direction. So I'm going to take furthest point on the left, furthest point on the right. We'll bisect that angle so that we can find the center of the object, to which I will point my camera. So the center line of vision is in this direction here. CLV, and the picture plane would be 90 degrees to this. Degrees to the CLV, so the screen of your phone is 90 degrees to the camera lens. Touching corner A. picture plane. And our vanishing point is going to be parallel to this surface, so our vanishing point is going to be at a 45-degree angle. That gives me my VPL, 45 in the opposite direction. Gives me VPR. This is A, that's B, that's C, that's D, this is E, and F. I would say 1, 2, 3. 1, 2, 3. And then this would be 4, 5, 6, we'd say, for example. Okay? So just label in all of our points, and we can say T and S. For our door here, it is a measurement of 30 millimeters, so I'll step out by 15 and 15. So 15 this side and 15 that side. Okay, so PQ. The end of the door. Alright, and that gives us a good start to the question. Now, what I could do is you can untape the sheet and you can draw your horizon line and ground line in a parallel position, but I'm just going to use slide and set skirt here for now. I know that the object is above the eye line of the spectator. Because the spectator is a height of 65. So we have a building or a greenhouse that's 45 plus a slope of 35 degrees, so I'm presuming it's going to be bigger. So there we have our horizon line, HL, HL, and then the distance away from these, the space away from these is 65 millimeters. So pointing this direction to the CLV, 65 is here. Again, we just go parallel. And that is our GL, ground line. Okay. So, majority of my question there on the screen. What I am going to do is I'm going to untape it and just rotate it slightly so that bring in any of my lines I can get it my T-square. Okay, so now that's like so. I can take corner A and I can bring corner A down vertically to create my reference height line. And any heights of the building I can apply to this. So the height of the building is 45. So I'm measuring 45. So I'll bring down my vanishing points. VPL comes down. VPR comes down. Level up. VPL. VPR. My two ground lines. I will then bring down my point D. B where it hits the picture plane. My height of 45 will go across to the VPL and to the VPR. And then I'll draw my height in. Any lines of assurance, I will draw them in heavier. To make them stand out. Okay. Now, I'm also going to get the door, so Q yeah. And now what I'm going to do is I will also just bring 1, 2 and 3 to the eye of the spectator. See you later, guys. Now, in order to get the auxiliary vanishing point, what I'm going to do is I'm going to take the slope of 35 degrees. Yep. Okay, so I am going to do the slope of the roof, okay, for here, so it's sloping uphill this way. Okay, as it's getting further away from you. So therefore it is an angle of 35 degrees. And I'll take my protractor and I'm going to measure an angle of 35 degrees. And I'll draw in this angle of 35 degrees. Now it doesn't matter if you do it on this side or to the left. Okay, so you can do it on either side, it doesn't matter. As long as it's linked to the VPL, that's the most important part. So you can measure your 35 degrees this way. And you can join your line there, doesn't matter. So either purple line will work. And then from our VPL, as long as we go 90 degrees to the vanishing point line, where that cuts that height is what we're going to use. Okay, if I went this way as well, it would give me the exact same information. So if I went from here, got that purple line, that would be the exact same measurement. So I'm now going to take that measurement with my compass. And we applied above the vanishing point line on the left, the VPL, to create our auxiliary vanishing point. So this point here is what we call our auxiliary vanishing point. That is the vanishing point for the slope. So at the top of A, at the top of D, we can bring these 2 points, and 1, 2, and 3, we can bring them all to the auxiliary vanishing point. Okay, and now we need to figure out where the apex of the roof is. So if I continue with my normal skill set of bringing the highest point of the roof, the apex of the roof, the ridge of the roof, labeled as point E to the eye of the spectator, where it hits the picture plane, we bring that straight down, and where that cuts then gives us E. I can then bring that back to my vanishing point on the right hand side. The line EF is parallel to VPR. And so therefore I now have the ridge of the roof. Have my different roof elements, or glass panels. Also constructed. Okay, and then E will come back down towards there. And then for the door, we have P and Q. There's the hinge of my door. If I bring that through VPL, it will give me the height of my door, giving me the location of Q, which both match up. Okay, so there's the location of the door. So that is part A of the question. Alright, finding the auxiliary vanishing point of the slope of the roof. Now, we're going to the next part, which is the door. And part B here of the door is the hinges at P. It's going to open up from a closed position. It's going to open up till it gets parallel with the picture plane. So we're going to open this, rotate this open until it becomes in a parallel position with the picture plane. Picture plane I have set up to my set square, or to my T-square to be horizontal. So it'll open up to a horizontal position. Q is now positioned here. Okay, and we're going to then find that in our plan view. So if I bring now PQ is parallel to our picture plane. Our picture plane is horizontal, ground line is horizontal, horizon line is horizontal, therefore PQ on the ground is going to be in a horizontal position. And at the door, top of the door, how do we figure out where that stops? So what we do is the same what we've done for every other point. We'd bring Q to the eye of the spectator. Q comes to the eye of the spectator where it hits our picture plane. We're going to bring that down. That will give us the location of our open door. It should be a perfect rectangle as it is parallel to the direction that we're viewing. Now, part C of this question then is our window here, which is going to open up. Okay, so this purple window here is going to open up to an angle of 70 degrees. So the question here says, on your perspective drawing, show the roof window when it has opened through an angle of 70 degrees. Now this angle here of the roof is already at an angle of 35. And so if we were to continue this window on in this direction. And we take our window and we rotate it open. That is going to be your angle of 70 degrees. So this slope of 35 degrees, but it's going downhill as it gets further away from us. Okay, so it's going to go downhill as it gets further away from us. So we're going to use the exact same angle or slope of 35 degrees, except this time I'm going to take that measurement of H and I'm going to apply it below the horizon line. Continue down our VPL. This is our auxiliary vanishing point 2. And what we'll do is from this auxiliary vanishing point where it meets the ridge of the roof at 2, draw it up this way. I'm just going to draw it in red. Actually, draw in orange just so it's highlighted. Okay. Come up that way. Same thing will happen going through 3 at the ridge of the roof. Okay, like so. And then we're going to need to find out where does that window stop. So, if I take either T or S and I find its location in my front elevation or my perspective view, I can then join through VPR as TS is parallel to VPR. So if I take S to S, S to the eye of the spectator, where it hits our picture plane, down in orange, giving us this point here for S. And if I join that through VPR, it should then give me TS. There's my window open through an angle of 70 degrees. There's my purple window open. Okay, so that's that question solved. I'm missing the vertical elements here of and that is the question fully solved.